Hello, ladies and gentlemen. So today we're going to look at properties of logs, which is expanding and condensing them. What these are going to help us later is to solve equations using logs. So it's going to be a lot easier once we start actually solving equations when there's a log in them. Here's some properties you're going to definitely want to get down. So this works for logs and natural logs, ln if you remember. So a product inside a log. So you notice how it's a times b here, right here. What you can technically do, you can separate that a and the b with two logs, and you can add it together. So you're going to be log base a plus log base b. Okay, it's kind of a little weird, but associate multiplication with addition. Kind of attach those two together, okay? Log of a quotient. Log of a divided by b equals log of a minus log of b. Okay? Now you're thinking, how on earth did someone ever come up with these? But bear with me. Log of a to the b power equals b times log of a. What these are going to allow us to do is either simplify an expression or make it a lot more open, a lot more expanded, bigger looking. It's going to help you break down these logs and simplify stuff so you don't have to have as much inside a log. So you're saying, why? How are we going to do this? Why are we going to do this? So we have log base 2 of x equals the exponent, right? When did you add your exponents? When you had similar bases, right? Something like this, 2 to the 4th times 2 to the 3rd. Well, you added them. So when we're multiplying on the inside of our log, you're going to add them. So it's kind of, you're using your exponent rules in a different way. You're using the exponent rules to explain and expand these logs and make them smaller or make them bigger. So like this one, you would get 2 to the 7th, right? Well, you could expand that. If you would have had a 2 and an x inside of a log, you would expand that to get log of 2 plus log of x. It gets you that x out of the way. When did you subtract exponents? When we were dividing, right? So your dividing is equal to subtraction, even in your exponent mind. So you got to kind of keep that in your head. And then when did you multiply exponents? When you had a number on the outside, right? So that 4 is going to technically go in front. That's the multiplying. So you've used these rules before. You have. You just haven't really realized that they can expand to the log section of our mind. So let's actually work on a few problems like this. Expand examples. So they have log base 3 of 4 times x. So now, in our mind, we need to think multiplication equals addition. So what we're going to do is we're going to write log base 3 of the first guy, 4, plus log base 3 of the second guy, x. That is the final answer, is that one. So however many terms you have inside tells you how many logs you're ultimately going to end with. So if you have 3 things inside, you're going to have 3 logs at the end when you're expanding. So we're doing division here. Notice how there's division. So let's simplify. Let's expand. So in our head, we're going to think division is equal to subtraction. So we got log base 10 of 6 minus log base 10 of y. So I am now simplifying. I'm taking the inside and making it simpler to get to. It makes it a lot easier when we're actually going to start converting and solving for things. What about log base 3 of x squared? So this power right here, he can't be sitting up there. It's very hard to get to. So what you can do is you can take this power and give it and put it into the front as multiplication. So it'd be 2 times log base 3 of x. So the exponent is going to become multiplied by that log, ultimately. What about some more expanding? Notice how these are getting a little bigger. So I have 3x squared. So I have multiplication, right? So multiplication is equal to addition. So let's simplify. Let's put these into its own logs. So log base 4 of 3 plus log base 4 of x squared. Now, I'm not done though. I'm not done expanding. I have a power left. I can't leave that there. So we would have log base 4 of 3 plus, this power's got to go in the front, right? So 2 log base 4 of x. That is as simple as he can be. What about this bottom one? Natural log of 6x divided by y. So natural logs work on this too. So let's do the top and the bottom. Let's first take care of this division first. So I have the natural log of 6x minus the natural log of y. Okay? Done with the division. But now I have multiplication inside. Notice how there's multiplication still, right? So let's simplify that further. We have the natural log of 6 plus the natural log of x minus the natural log of y. So what I did, I put that in parentheses just to show that that is multiplication. It ultimately is going to end up on the top together. That's why I put parentheses around there. So notice how there was 3 different things. 1, 2, 3. I have 3 natural logs at the end. So count, you can think it in your head. That way you know who's going to attack, when you're going to do certain things, all right? Now, condensing, working backwards. I think these are a little harder sometimes. So, I have log base 7 minus log base x. So, instead of subtraction, so the opposite of subtraction we said was division. So, I'm going to put 7 over x. So, the first guy goes on top, the second guy goes on bottom. Alright? What about this one? I notice I have 2 in the front. Very first thing I'm going to take care of is I'm going to put that 2 back to the x. So I'm going to have log base 3 of x to the second plus log base 3 to the y. Okay? Then what I'm going to do is I notice I have addition, right? So addition was equal to multiplication. So log base 3 of x squared y. So ultimately, on condensing, you should always end with just one log. Alright, just one. Big behemoth. This guy is huge. So let's start looking at it. First things first. Take care of the things that should be powers. So this 3 and this 4. Take care of them first. That guy's going to go there, and that guy's going to go with that one. So I'm going to have log base 2 of 5 to the third plus log base 2 of x minus log base 2 of y to the fourth. Alright, so then let's take care of the multiplication. So this addition part right here. So I have log base 2 of 125, right? 5 to the third, 125. 125x, so I put these two together, made them into 1 because it's addition, right? Minus log base 2 of y to the fourth. Subtraction is a division in disguise, so 125x over y to the fourth. This is equal to that mess up there. Why are you learning this? Well, it's going to help us solve equations ultimately. So what I can do with this is I can make this condensed. So I can make this log base 10 of 3 minus, notice how this 2 needs to go to the x, so log base 10 of x squared. That's technically log base 10 of 3 divided by x squared, right? And this equals 16. So now, what I can actually do, I can convert this into exponential form because I have only one log. So we would have 10 to the 16th equals 3 over x squared. Pretty cool, right? So now I can multiply by x squared on both sides and divide by 10 to the 16th. If you're okay with that, I'm going to go do multiple things at a time. So I'm going to have x squared equals 3 10 to the 16th. I'll square root both sides, and you'd be left with x equals plus or minus the square root of 3 over 10 to the 16th. Now, the ones you're going to do in class are not going to be that bad of an answer. They're going to be a nice answer. We're going to talk a little bit more about this when you get to class. We're going to spend 2 days on this section. So we're going to do a lot of practice because I do realize this stuff is a little hard. But that's the end of this video. This is Miss Marsh, signing off.